welcome back to our YouTube channel Learn Together 2026. And our today's topic is metals versus non-metals, the real chemistry battle. So this is chapter number 4, CBSE board, grade 10, and let's move towards our topic. But before that, I would ask you all to like, subscribe, share for more information. Let's move towards the next heading, that is physical properties. The physical properties of metals and non-metals are they all are listed over here. Okay, so the very first property is luster. Luster means the shine, the appearance is good in metals, whereas non-metals are non-lustrous. But there is an exception, a non-metal which is lustrous also, that is iodine. When we talk about the hardness, then metals are hard, whereas non-metals are soft and brittle. But there are exceptions in both the cases. Lithium, sodium, and potassium are brittle, though they are metals, whereas non-metals are soft brittle. But diamond is the hardest uh, material found on Earth, right? If we talk about malleability, so basically the malleability is a property by which a metal can be beaten into thin sheets, and it is possible in all the metals, and gold is the most malleable material. You must have seen some sweets are there which are wrapped in gold foils, so they are malleable in nature. But there are three metals which are non-malleable, are lithium, sodium, and potassium. All the non-metals are completely non-malleable, and there are no exceptions in that. Now, next property is ductility. Ductility means can be beaten into thin wires, and as you see that gold is the most malleable substance, because the jewelry which we are wearing, the things, rings, whatever we wear made up of gold can be molded into in any form. So gold is the most ductile, right? So there are three exceptions: sodium, lithium, and potassium. And when we talk about non-metals, they are completely non-ductile. If we turn towards the next property, thermal and electrical conductivity, the metals are good conductors, except basically this is not except, this is silver is the most um, good conductor, whereas bismuth is the poor conductor in metals. And in non-metals, all the non-metals are bad conductor of electricity and heat, but graphite is a good conductor, and yet it is in non-metals. Now we talk about sonority. Sonority means when we hit with a hard substance, they produces sound. That is sonority. And metals are generally sonorous, and non-metals are non-sonorous. Tensile strength. Metals are having high tensile strength, whereas non-metals have low tensile strength. Density of metals are high except lithium, sodium, and potassium, and non-metals have low density. When we talk about melting point, metals are having high melting point and boiling point except lithium, sodium, and potassium, whereas non-metals have low melting and boiling point except graphite and diamond, because they are having a very high melting and boiling point. If we talk about states of matter, then they are generally solid. Metals are generally solid except mercury. You must have seen mercury thermometer, and it is not solid at all. And when we talk about non-metals, so non-metals exist in all the three states: solid, liquid, and gases. So let's move towards the next slide. Chemical properties. So let's move to the topic. that is chemical property. If we react any metal or non-metal with oxygen, whatever the reactions are there, we have to understood in this topic. Metal plus oxygen gives metal oxide. Metal oxide means whenever metal is added with any of the with oxygen, right? So this is magnesium reacts with oxygen, gives out magnesium oxide. Same goes for copper. Oxygen gives copper oxide. There is one exception. If you can see that sodium and potassium catch fire in open air, thus stored in kerosene. So it is not required for sodium and potassium to be uh, left open anyway. Now moving towards the next heading, that is the reaction of oxygen with non-metals. So non-metal plus oxygen produces non-metallic oxide, and they are always acidic in nature. Like carbon reacts with oxygen, produces CO2, that is acidic oxide. Now next is reaction with water. So what will happen if you react metal with water? You will be producing metal oxide, and when this metal oxide reacts with water, again it produces metallic hydroxide. So suppose you have taken sodium with water, you are going to have eventually NaOH plus hydrogen gas. Whereas when you react non-metal with water, they generally do not react with water or steam. Let's move towards the next property, that is reaction with acids. So when we are having acid and we have to react acid with any of the metal, the only thing which you have to be clear in your mind, it produces hydrogen gas. So be very careful that whenever you react metal with any HCl or H2SO4, it will give you hydrogen gas. And when you react metal with dilute nitric acid, it will give you salt, water, and oxides of nitrogen. Because this is one of the exception, that nitric acid does not give hydrogen gas with any metal, right? As it is a strong oxidizing agent, but it gives hydrogen only with magnesium and manganese. So whenever you have taken nitric acid with magnesium and manganese, among the two you can take any one, so that will give you hydrogen gas. But if you have taken magnesium with nitric acid, yeah, manganese with nitric acid, it will surely give you hydrogen. But you have taken calcium with nitric acid, no reaction. Or it will give you reaction, but that will not produce hydrogen gas. So this is one of the exception. And when non-metals are treated with acids, they do not displace hydrogen from acids. So basically there will be no reaction at all. Last of the topic, reaction with salt solution or other metals. Other metal के salts we can take. So that metal A will displace metal B from the solution, and it will create salt solution of A, and metal B will be displaced. But this will all depend on the reactivity series. If you understood the sequence of reactivity series, then only you will master this equation. Because in this reaction you have to be very careful that whatever the reactivity is happening is because of the positions they all have. If we have taken an example of zinc reacts with copper sulfate, so in the reactivity series, copper is below zinc, so it will displace zinc sulfate, and it will make zinc sulfate and displace copper. But if you have taken copper with zinc sulfate, and then this copper will never be able to displace zinc, as it is lower in reactivity series. So there will be no reaction at all, right? So this is for the chemical properties. Let's move to the next slide. This is ionic compounds. The properties of ionic compound is hard and brittle solids. They have high melting and boiling points, water soluble and insoluble in kerosene oil. They all conduct electricity in aqueous solution. and in their molten state, but they do not conduct electricity in their solid state. Basically, ionic compounds are formed by transfer of electron from one atom to the other atom. The atom which will donate electron is a metal, whereas the atom which accepts electron is a non-metal. If you see this example, this is the sodium, and it has one electron that will be transferred to chlorine, which is already having 7 electrons in the outermost shell. So it will give you NaCl, in which Na is positively charged and Cl is negatively charged. If you see magnesium chloride, so this magnesium is having 2 electrons in the outermost shell. So it will donate 1 electron to this chlorine and 1 electron to this chlorine, and it will form MgCl2. So in this way, when the compounds are formed by complete transfer of electron from an atom to the other atom, this is called ionic compounds. Let's move to the next topic, occurrence of metal. Metals always exist in two states, combined state and free state. Combined state, sodium, calcium are found in their combined state, and they are present in two forms, one mineral and other one is ores. Minerals are the naturally occurring elements or compound found in Earth's crust with a definite chemical composition, whereas ores are the minerals containing economically valuable concentration of certain metal that can be profitably extracted. So this is the way that ores are one of the minerals. In this we can say that all minerals are not ores, but all ores are minerals. And when we talk about free state, the metals like Ag, Au are usually found in their free state. Okay, so now move towards their process of extraction, that is known as metallurgy, and the three steps involved is enrichment, extraction and refining. So get in detail. Enrichment of ores. What is the meaning of enrichment of ore? The process of removing unwanted impurities, which are also known as gangue, from the ores is known as enrichment of ore. There are several methods, but they are not included in CBSE. So we just have to understand that whenever we are going to have ores with us, we first have to enrich them and removing the impurities. Next is extraction of ore. Extraction of ore means the process of obtaining metals from their natural forms, involving mining the ore, concentrating it by removing the impurities through different methods. So extraction is having three steps and three different steps in which you have categorized low metals, middle metals of reactivity series and high metals of reactivity series. Suppose you are going to cook food, so you are not going to use the same method for all the substances you are cooking, just because whatever the substance is cooking you are going to cook is going to have a specific recipe. In the same way, extraction of ore is not same for all the metals. Every metal is having a specific reactivity, and then the process of extraction is also specific to them. So let's move. So this is one chart in which you can understand the concept that how the hierarchy of concentration of ore will take to purification of metal. So in this method, whenever in this process, whenever you are having metals of high reactivity, they will be they will be purified by using the process of electrolysis, and then you will be getting pure metal. But when you have middle reactive elements, then they are of two types, carbonated ores and sulfide ores. Whenever carbonated ores are there, you have to perform the process of calcination, but if you have sulfide ores, you have to take the process roasting, and they both will lead to the formation of oxide of metal. Then you will go for reduction, and then you will be getting the pure metal. This is very important for your boards. And metals of low reactivity will undergo sulfide ores, then roasting, then metal, and then refining. So let's move towards the process of extraction. Metals low in reactivity series is basically copper, and the other one is mercury. Copper is, whenever you are having copper, it will be copper glance, Cu2S, reacts with oxygen, heat, and gives you Cu2O. And then in the next step, Cu2O will further react with Cu2S, that will give you copper, that is the purified copper. And when you go for mercury, this same will happen. HgS we will take with reacting oxygen, give you HgO, and then again in the second step this HgO will heat and gives you Hg and O2. So this is the process we usually take for the metals low in reactivity series. Next one is metals middle in reactivity series. They will go, as I already told you, they will go undergo calcination and roasting. Roasting is for sulfide ores, calcination is for carbonated ores. Roasting is unlimited air supply, and calcination is limited amount of air is supplied to the process. This is done for zinc and iron. In zinc we are having ZnS reacts with oxygen, gives ZnO. This is the process of roasting. And when we are having carbonated ore, ZnCO3, it will give you ZnO and CO2. And in both the after both the steps, we will follow the last step. This one, ZnO plus carbon gives Zn simply. And when we go for extraction of iron, Fe2O3, aluminium, FeAl2O3, and heat. So this is done for the metals middle in reactivity series. Metals high in reactivity series undergoes electrolysis. So in that case you have to use electricity. Anode will be there, cathode will be there. Anode will be having a negatively charged atom, and cathode will have a positively charged atom. So this is not very much asked in your CBSE board exams, but yes, this is one of the topic present in NCERT book. Next one is refining, that is the final step. So it is basically the removal of impurities from extracted ores, and in this you have to understand electro refining of copper. This is basically for ICSE grade 10 syllabus, but sometimes they can ask in CBSE also a very small multiple type question. So in that case, anode will have blistered copper, that is copper 2 plus 2 electrons there, and cathode thin strips of pure copper. So basically pure copper is deposited on cathode only, right? Let's move to the next topic, important ores for CBSE board. So you have mercury metal, and the metal is HgS, named as cinnabar. Okay, whenever you are having cinnabar, you will have to do roasting. HgS reacts with oxygen, gives HgO and SO2, and further this HgO reacts and gives Hg and oxygen. The next one is extraction of copper metal. So if copper metal is there, you are having copper glance, Cu2S, and this is also roasted because it is one of the sulfide ores in the unlimited amount of air. Cu2S, oxygen gives Cu2O, and then again this Cu2O will react Cu2S, gives copper only, right? So this is for copper glance, important ore of copper. Next one is extraction of zinc, and zinc is having both the existence of both the ores. The first one is zinc blende, which is called ZnS, and the other one is calamine, ZnCO3, zinc carbonate. As ZnS is a sulfide ore, it will undergo roasting, and ZnCO3 being a carbonated ore, it will go into calcination, right? So basically the step which will be there in both the things is that NO plus C gives zinc only and carbon monoxide. Before step we already has discussed in previous slides. Next one is thermite reaction, very important reaction of class 10th CBSE board exams. Thermite reaction is having a very versatile usage in railway carriages and welding industry. In this case you have to use iron with aluminium. If you are going to use aluminium powder for the welding process, then that is said to be a thermite reaction. Metal oxides are heated with aluminium as a reducing agent to reduce to metal. The example is of thermite reaction. When manganese dioxide and iron oxides are reduced to respective metals when heated with aluminium. And kindly make sure whenever you are using this type of uh, answer writing, do mention the reactions, because these reactions will give you extra marks. Okay, so thermite reaction has a very good application. The thermite reaction is used for welding the electric conductors, iron joints, such joints on railway tracks. This is known as thermite welding. So I hope you all have understood the topic of metal versus non-metals, all the physical chemical properties and reactions, whatever the process of extraction of ores in which your middle reactive elements are very important. And I just want to thanks all of you for watching my channel Learn Together. I request you to like, comment and share, and if you want to be notified for my channel, do subscribe my channel. Thank you so much.